All right, hello and welcome to Evaluating Functions. So we're going to continue to build on what we did last time where we plugged numbers in for X and figured out what Y was, remember input, output. This time we're going to do the same thing, only we're going to use what's called function notation. So when a function passes the function test, and it is a function, there's another way you can write it. And functions are usually given names, not like Bob or Fred or Sally, but we name them with letters. So a lot of times we say function F or function G or function H. Those are pretty much the most common names. I don't know why. And then we also name them by saying what the input variable is. Okay, so what that looks like up here is we take a normal equation like right here, y equals 2x minus 8. And the way we turn it into a function is we say f parentheses x equals 2x minus 8. Okay, now mine didn't fit, I had to go outside the box. And the way we read that is we say f of x. So we say the function f that has x as an input is 2x minus 8. So we read it as f of x is, and I'll just write 2x minus 8 like that. Okay, so if you look down here, we would say f of x is 1 minus 3/4 of x. H of x is x squared minus 5x plus 7. G of x is negative x squared plus 10x minus 3. So later on in math, you're going to look at multiple functions at the same time, and that's the way we name them is we give them different letters. Okay, so what we're going to do is we're going to use function notation, and we're going to figure out the value of the function at a certain point. So we're basically taking inputs and putting them in and figuring out the output. And we say, oh, the value of the function at 3 is 10. And we get the ordered pair 3, 10. Okay, and it's going to allow us to do lots of things later, like graphing and figuring out answers to complex word problems. So let's look at example number 1. We are going to we have the f of x function, and we're going to find the value of the function at negative 12. So that's what that negative 12 means in the parentheses. So I'm going to do 1 minus 3/4, and I'm going to plug in my negative 12. Okay. Now, using order of operations and cross canceling, I'm going to solve. So let's see, 4 goes into itself once. 4 goes into negative 12, negative 3 times. And just like I was saying in the last lesson, I group the signs together. So in my mind, I see that as 1 plus 9, because negative 3 times negative 3 is 9. So the final answer is f of negative 12 equals 10. So that actually turns into an ordered pair. I could plot the point negative 12, 10. I'm not going to though. Okay, let's find the value of the function at 0. It's always my favorite one to plug in because it's the easiest one, right? 1 minus 3/4 of 0 is just 1. So the value of the function at 0 is 1. Okay, and that's fine if for the zeros, you want to just do that. There's not really a lot of work to show. Okay, let's find the value of the function at 4. So I get 1 minus 3/4 times 4 over 1. So my 4's cancel. 1 minus 3 is negative 2. So the value of the function, at 4 is negative 2. So I could plot the ordered pair 4, negative 2, but we're not going to yet. Okay, cool. Let's look at another example. Notice this one's a little bit different. It's got a squared term in it. Okay, so this is going to end up being a curve. This one doesn't have a squared right here, and that's going to be a straight line. A squared ends up being a curve, and you'll learn more about those later. So we've got to be really careful when we square numbers because negative 5 squared is not the same thing as negative 5 in parentheses squared. So anytime we plug in a negative number in squared problems, we've got to use parentheses. Okay, so just as a quick reminder, exponents have really bad eyesight and they can't see well unless they're wearing their glasses, which happen to look really similar to parentheses. So this squared sees the negative 5 and the negative 5, which gives us 25. This squared can't see very far, no glasses, so it only squares the 5. 5 times 5 is 25, and then you got to stick the negative sign back on. So this would actually equal negative 25. So let's just be really careful, and I'll model that as we plug stuff in so you can see how to get the right answer on these. Okay, so I'm going to plug in 2. What's the value of the function at 2? So I get 2 squared minus 5 times 2 plus 7. Okay, order of operations, 2 squared is 4. I look at it as a negative 5 times 2, which gives me a negative 10 plus 7. 4 minus 10 is negative 6. Negative 6 plus 7 is 1. So that equals 1. So h of 2 equals 1. And there's my first ordered pair. Okay, now let's plug in negative 5. So I get negative 5 in parentheses squared minus 5 times negative 5 plus 7. Okay, remember, negative 5 times negative 5 is a positive 25. And another negative 5 times another negative 5 is also positive 25. So that gives me 57. So the value of the function at negative 5 is 57. Okay, if I'm going a little fast, feel free to pause or go back. And if you don't really have enough room, just find some room off to the side to do the work. Okay, so let's see. Let's plug in negative 8. What's the value of the function at negative 8? So remember, put it in parentheses, negative 8, parentheses squared, minus 5 times negative 8 plus 7. Okay, negative 8 times negative 8 is a 64. Negative 5 times negative 8 is a positive 40 plus 7. So what is that? 104 plus 7, 111. So the value of the function at negative 8 is 111. Ooh, good thing we're not graphing that one. Those are really big numbers. Okay, cool. Now we're going to do all the examples on this page just because they're all different. Yeah, look at number 3. How is number 3 different? Did you see it? There's a negative sign, boop, right in front of the x squared. So this is tricky. Organization is key in this problem, okay? So I'm going to write the negative sign. So we're evaluating this function at 9. So I write the negative sign, parentheses 9 squared. Notice I didn't put the negative in parentheses because I'm squaring 9, not negative 9. Okay, plus 10 times 9 minus 3. Okay, order of operations, I'm going to square first. 9 squared is 81. And then I bring down this negative sign and stick it in the front like that. Okay, 10 times 9 is 90 minus 3. Okay, negative 81 plus 90 is 9. 9 minus 3 is 6. So the value of the function at 9 is 6. All right. So this is just lots of practice of order of operations in different functions. Okay, now let's do a negative 1. This is tricky. So I got my negative sign. Then I plug in negative 1, and then I square it. Plus 10 times negative 1 minus 3. So negative 1 squared is 1. Don't put 2. Some people accidentally put 2. There's a 1. Bring down the negative sign. 10 times negative 1 is negative 10 minus 3. Negative 1 minus 10 is negative 11. Minus 3 is negative 14. So the value of the function at negative 1 is negative 14. Okay, how we doing? You feeling okay with that negative sign in front of the squared? It's really just organization and order of operations. All right, last one, negative sign. Plug in negative 3 and square it. Plus 10 times negative 3 minus 3. Okay, negative 3 squared is 9. Bring down the negative sign. 10 times negative 3 is negative 30 minus 3. Sorry, that's not a very good 3. Okay, 9 minus 30 is negative 39. Minus 3 is negative 42. So the value of the function at negative 3 is negative 42. Okay, cool. All right, last one where we plug stuff in, absolute value. So if you don't remember, absolute value happens at the P step of PEMDAS. So I have to do everything inside the absolute value symbols and whatever, and all the way down to one single number. And then I have to ask myself, how far is that one single number from 0? And that's my answer. And hint, they're always going to be positive. Okay, So I like to draw my absolute value symbols really tall, so I don't think they're a 1. Happens all the time. 1 minus 7 times 1 absolute value. So that's how I draw it. Okay, 7 times 1 is 7. 1 minus 7 is -6. Then I ask myself, how far is -6 from 0? And I say 6, because remember, distance is positive. So the value of the function at 1 is 6. There's my answer. Okay, now let's plug in -7. So big, tall, absolute value symbols, 1 minus 7 times -7, absolute value symbols. So again, I do the -7 times the -7, which gives me absolute value symbol 1 plus 49, big, tall, absolute value symbol, which gives me absolute value of 50. And then I ask myself, how far is 50 from 0? And the answer is 50. So then I write my answer. The value of the function at -7 is 50. And remember, those could be ordered pairs if we wanted them to be. Okay, last one. Absolute value 1 minus 7 times 9. Absolute value. 7 times 9 is 63. So I get absolute value 1 minus 63, which is -62. And how far is -62 from 0? The answer is +62. So the value of the function at 9 is 62. And there's my answer. Okay, so hopefully you're noticing it's all organization, taking your time, one step at a time, watching your negative signs. All right, I think you're gonna like this last one. This time we're evaluating, but we have a graph. So it's saying, here's my function, it's a straight line. What is the value of the function at -4? Remember, the number you plug in is plugging in for x. So they want us on the x-axis to go over to -4. Okay, so let's go over to -4. 1, 2, 3, there's -4. And now go up or down until you hit the line. In this case, I have to go up 1. So the value of the function at -4 is 1. Then I go over to 2, 1, 2. This time I had to go down, and I go down 1, 2, 3, 4, 5. So the value of the function at 2 is -5. So you go left or right, depending on what the x is, and then you go up or down, depending on where the line is, and then you name that the y value of that point. So what's the function at 0? I go down 1, 2, 3. So the value of the function at 0 is -3. Cool. I like those. Okay, so here's what you're gonna do. There are 3 on your own problems. Okay, you're going to practice plugging in with a -x², because those are the harder ones. Then you're gonna practice with a fraction, because we all need fraction practice. And then you're gonna read the graph. Okay, so take a minute and try those, and I'll come back with the answers. Okay, so here's what I got. So go ahead and take a minute to check your answers. For the 0 one, I didn't plug it in, but I did know that after I plugged in, that these first 2 would turn into 0, and then I just had -4 left. I had to do a little bit of work with my fraction, so I did a little bit of shortcut work. And then for number 3 was really interesting. This is a cubic function, and it curves a few times, and it actually hits the graph 3 different times at 0. Yeah, and that's actually what we're going to talk about in the next lesson. So those are called zeros of functions, and this function happened to have 3 of them. All right, so if you need to hit pause, you can. Apply the same idea to the homework. Remember to take your time and show all the steps, and so you don't miss these just for computational errors. Okay, cool. Keep up the good work. You're almost done with the unit.